Hello guys. Let's take a look at a protocol called KYVE. What is KYVE? KYVE. Um, just switch it back. KYVE. Enabling. If you use their website, when you go to their website, it's spelled out loud. Enabling limited scalability for Web3. But the main function of KYVE is building decentralized data lake. Now that might not make any sense at first, but as we take a closer look, it says KYVE is an initiative to store any data stream with built-in validation by leveraging the Arweave blockchain. You can permanently and immutably store this data. You see, the Arweave blockchain, ARWAVE. It's a blockchain that allows for permanent storing of data and in a decentralized manner. There are a lot of problems with our normal data system, be it Web2, and even turns out that even on blockchain, even though when you say data is permanent, there can be a little bit of problems when it comes to storing this data. And if you take a look at the Arweave blockchain, you can see they say from a temporal perspective, retrieving arbitrarily long sequence of data can be burdensome. Like when even on the blockchain, trying to retrieve a large number of data is actually something that's not that it's not it's not easy. It takes a lot of times. So I wrote an article on this, and this is it. So let's say when it comes to off the blockchain, there are a few problems with off and both off and on the blockchain. Off blockchain, let's say you have your file stored on a website, a server. These are Web 2.0 platforms. The server could go down. Um, Depending on how far the information you're looking for is on archive on the website, you might have to sit down and just like press search or like wait for a long period of times. And if you're talking about hard drives get damaged, things can happen to hard drive, get lost and become corrupted. That your data, getting your data, becomes a little bit of problem. And even on the blockchain, when it comes to large or serial data files on blockchain, it's not easy to like sync them up. And I use an example of this sort of like and it's in their light paper too. When it comes to nodes, nodes are basically like in the blockchain. We know what nodes are. Nodes are like full node users. These are the people that deal with the validation. They are the validators basically. They are the ones that verify the data that's coming up onto the blockchain. Miners or validators, depending on the blockchain you're talking about. If it's proof of work, we're talking about miners. If it's a proof of stake, we're talking about validators. Before they can add any block of data to the blockchain, these blocks have to be verified, and it's the process. The people that verify them are called node users. So when a new node joins the club, on the blockchain, verify data because they added to the blockchain. But when an upgrade takes place, such as add fork, this data they take a bit of time before they can be synced up onto the new chain. That this is because the node has to get the information from as to all the prior data that has been on the blockchain, and before it syncs up with that, it takes pretty long period of time. And there are also some times when some data there are also data complications when it comes to the blockchain, like in terms of, let's say, when you're doing a cross-chain transaction. I don't know if you guys have tried doing cross-chain transactions for. Yeah, obviously you've tried. When it comes to cross-chain transaction, let's say you're doing a transaction, let's just say on Binance Smart Chain, just speaking normal chain, Binance Smart Chain, you do your transaction, you can go to your BSC scan, follow up your transaction and see exactly what went through with the smart contract and everything. When it comes to cross-chain transaction, you can't really follow through. You just like follow it up to an extent like, oh, it's missing, like what next? With KYVE, these things become very, very easy to find through retrievable. They actually they store it in the form of pictures, screenshots, snapshots, and then they can be easily retrievable fast. And problems like following a cross-chain transaction become very easy with KYVE. So KYVE allows developers and applications to store and retrieve any data stream. It's fully decentralized, validated, and efficient. We should also know that I said the KYVE network, the KYVE protocol, KYVE network, it leverages the use of the Arweave blockchain, which is a blockchain that allows for permanent storage of data. The KYVE itself also has its own network, it's built on the Cosmos Hub. And if you're familiar with the Cosmos Hub, it's tender mints that allows for easy building of a blockchain where a lot of the things are already like figured out. If you're using Cosmos Hub, it's definitely proof of work. So basically, this allows the KYVE to be able to like easily connect with all the blockchains in the Cosmos Hub already. That's just like that's making sense. It allows KYVE to focus on what KYVE does, and they having a blockchain, and then sort of the basis of their blockchain comes to be the Arweave protocol. So if you go into the introduction, KYVE, okay, we've gone through this. Let's see the basics. KYVE network. KYVE is a network of storage used to store data streams or create snapshots of existing data. If you check out light paper, you can see here where it says the framework compacts any configurable data stream into readily retrievable snapshots, leveraging Arweave to create permanent backups. KYVE ensures the longevity of this data over time. Naturally, data is useful only to the extent that it can be proven valid, especially when it to be stored immutably, meaning you can't change it, such as the meaning of immutability. Invalid data can be the result of faulty transmission or storage processes or a result of interception by malicious actors. So you can have some times where the data itself, let's say an error occurs, KYVE is done in a way that, and this is the next line, KYVE is done in a way that any of these errors are sort of fixed through their validation system, and then you can sort of follow how the data went through. So with this in mind, any errors that may have occurred at previous junctions along a data element's lifecycle are gracefully caught and handled by KYVE's built-in and fully configurable validation step. So basically that's what the KYVE is, allows for permanent storage of data. It's like, when we're talking about the blockchain, decentralization and everything, this is something that's like that's important and like that's really, really, really like helps to keep the longevity of the data of the blockchain and everything is just stored and anybody can retrieve it anytime in form of snapshots. So we've talked about the KYVE being a proof of stake protocol layer system over the chain layer, and it was the actual use case of KYVE. Every feature and unit of logic which makes KYVE unique is implemented directly into the chain. This includes pools, funding, staking, and delegating. Like on the KYVE protocol itself, on the KYVE protocol itself, before you to be able to perform any task, you need to the main few things that you need to know. You need to know about the pools, you need to know about funding, you need to know about staking, delegation, and slashing. And these are besides delegating and slashing and staking, something that you might be familiar with. So at least we are talking about proof of stake system. But just know the basics. KYVE, allows for permanent storage of data. That's the main that's what KYVE is mainly for, permanent storage of data. And it's not like I said like people that are already using KYVE, we already have our users, our backers. So you have Solana, Avalanche, Cosmos, Arweave, Moonbeam, Octopus, Celo. You see all these blockchains, they are all like already using the KYVE protocol to sort of store their data and make the data on their blockchains, last longer and easily retrievable for them if they're trying to find anything. It just becomes very easy through the KYVE protocol. And then you see a few of the users here. You got Avalanche, Cosmos, Moonbeam, Near, Zilliqa, Solana, Celo. So just a lot. You can see that so like the blockchains itself are already using it. So it tells you how like important the KYVE network is and how important what KYVE is trying to accomplish is. So the KYVE has its native currency, which is the KYVE on the KYVE blockchain. Like I said, it's a blockchain on its own on the part of the Cosmos hub. So the KYVE, being a native token, you require it to perform any transaction is occurring on the KYVE network. You require to have the KYVE token. You're going to use it for governance. You're going to use it for staking, delegating. For pools, in the pools, you're going to require KYVE, be it if you're trying to fund, stake, delegate, and it's also what is going to have to be put down by nodes or validators. So they make sure that they behave accordingly and they don't like try to do any malicious attempts, as this could result in the slashing of their funds. So the KYVE token is very, very important. It's also used for the governance of the token, or governance of the KYVE network. And then this is a little sneak peek into the Arweave protocol, offers permanent decentralized storage. The web, we know that it's impermanent. Like a server goes down, a server gets fried somewhere in the world, that's the end. You can't retrieve that data no more. That's the only place that it's backed up on. But with Arweave, this offers permanent decentralized solution, and it's a blockchain. Decentralized nature makes it possible that if somebody's what do you call it, if a validator goes down somewhere, there's another validator up and running somewhere, and the KYVE blockchain is always going to be active as long as there's at least one validator that's alive. And that's the main nature of decentralization in its own. So this allows KYVE leverages the Arweave protocol to store its data. The pools general storage pools can provide discrete entities arranged around specific data source. Before you can before you can before you can upload data onto their use the functions of the KYVE protocol to upload data, you first have to create a pool. A pool is how everything else is going to work. And when you say you have a pool, then how does the uploading of data come through? How does the validating of data? So who uploads data? Who validates data? How do you retrieve data? And things like that. So let me quickly open up the article that I wrote on this. So a solution to I said KYVE allows for data old and new in any amount, like no matter the size, stored easily, and you can retrieve it easily with snapshots. We've talked about it. So one key protocol functionality is Arweave protocol, provides a permanent and centralized storage functionality. This makes the base and reliable for the KYVE network. You know that done. So we have pools, we have funding, we have staking, we have delegating, we have slashing, we have the KYVE token. But before I get into that, I want to talk about the how the uploading is done, how the uploading of the data is done and the retrieval of data is done. For uploading to be done on the KYVE network, you require validators or node users. So these node users are the ones that what do you call it, upload data source to a pool. Because a pool is basically like the storage pool. That's sort of like you can think about, like, so if you want to store a data, you have to create like a pool. Basically, I think of pools as like folders. So each pools is like a folder. Let's say let's just use the blockchains for example. Let's say Solana blockchain. Solana will have a Solana pool. Where all Solana data is stored. Bitcoin will have its own Bitcoin pool, and then so you sort of get like that. So for those pools to even be running in the first place, they require validators. These are the guys that you know that are running the KYVE network itself. They are the ones that are staking, they're the ones that are protecting the network. They are the ones that are validating any data that's to be added onto the KYVE, onto the pools in the KYVE network. They are the ones that are uploading the data. They're the ones that are validating. They are the ones that are, I think there's one more. I don't know. I've forgotten. Okay, retrieving the data. They validate, they retrieve, and they allow it to be stored. So they upload. So those three: retrieve, validate, and upload. So that's what the node users, which are the validators on KYVE protocol, do. And it's very, very important that we remember. It's very, very important that those are like functions. So let's go into the pools. I said pools, so we have some specific things that we need to know, is like pools. Storage pools used for storing data streams. Pool creation can be done through governance, and the data are verified before being stored and easily retrievable. So if you want to create a pool for a particular storage, you have to take it through. You have to write a proposal for it and then upload it to the governance, and then if it's passed, your pool is created, and then that's what it's done. But then we also have to talk about, so if this pool is done, so how do the validators or node users, how are they incentivized to keep on running the pools? You know, because this is a decentralized network. Like you have to sort of incentivize them, and this is where the funding comes in. For a pool to be created, right, it requires to be funded either by the project that owns the pool or the users that are running the pool. So let's say if Solana case, this could be Solana blockchain itself, which is the team behind Solana blockchain, or this could just be users of the Solana blockchain that are benefiting from it, and they just fund the pool. And then so whenever validators are trying to perform their daily functions, which is uploading, retrieving, or validating data, they the funding of the pool is basically what funds them. It's just like that. So KYVE node users who validate, upload, and retrieve data from the network are required to be incentivized, which is done through each pool's funds. Staking, just like the name says, if you're familiar with the blockchain, if you're familiar with the blockchain, everybody knows what staking is. Stakes basically sort of how you protect the network. You know, you stake certain amount of a native token, which ensures that validators act well and make no malpractice that could result in their stakes being slashed. Proof of work. I said proof of work. You have to do a lot of work, and that work comes from processing power. The higher the processing power, the higher the processing power of your proof of work system, the more likely you'll be able to like be the one to add the block to the blockchain. But in proof of stake, as the name implies, stake, you have to stake a certain amount of tokens for it to become a validator, and that stake sort of ensures that you do not upload wrong data, or you do not like validate a data without like, you don't validate the data properly and not trying to do any malpractice. Because if you do this and then you're caught, basically what happens is that your stakes get slashed, and then it has to be done in a way where the amount of funds that you are receiving for every task that you're doing as a validator, which is uploading the data, which is retrieving your data, which is validating the data, the amount of rewards that you do, it can be up to your stakes. It can't be up to the amount of stake that you put in the system as a validator. So this always ensures that, if you're trying to cheat on the system, you always have more to lose than gain. So which is always like, okay, so you've got to do the right thing on the right thing and the right thing. And that's where staking comes in place. So validators stake, and then users can also stake to participate in the pool and earn from the pool fund. So as a user, you can also stake, you know. So delegating implies users staking or delegating their tokens to a node to help secure the networks and earn rewards. So validators are staking. As a user, it will be your staking will be delegation, because you can't just stake anywhere. For you to stake, you have to delegate to a particular to a node. Sort of how let's say if you know how let's just use Cosmos for example. If you're on the Cosmos blockchain and you want to stake, you go to your Kepler wallet, you click on stake, but then you have to stake with one of the validators that are there, and that's just it. So you're also helping to protect the network by staking, and then you get to earn staking rewards. So if you want to delegate, you do so through the pools, and rather than staking to the pool, they delegate to any of the validators in that pool. So through the pools, and rather than staking to the pools, they delegate to any of the validators in the pool. So when you stake, if you want to become a validator, then that's the direct staking meaning. But as a user, if you're staking, you can say that the right time, the right proper time to use will be delegating, as you're delegating your funds, and then you earn staking rewards. And slashing, we've covered this. I didn't cover the three types that they are. They all warrant different percentage slashes. We an upload slash, of course. I think they on the document they actually go in depth in this. Slashing is a core mechanism in the proof of stake in KYVE. We also use nodes have skin in the game by letting their stake participate as a protocol node. So you want to participate, have skin in the game, put a little bit of stakes down. So that if you mess up, you have different types. You have upload slash, the vote slash, and the timeout slash. Upload slash is when you're trying to upload malicious documents, and then if you're caught, for you to be caught also, a majority of the validation, when you're caught, because this is a decentralized system, and then a lot of the activities that are done has to be voted on by the community. So even when it comes to the slashes, they still have to vote. The validators still have to vote and make sure that, oh yes, you did do this, and then the majority of the validators in the pool have to vote against your money. For an upload slash, you lose 20% of your stake, and that could be a lot of money. So, it's like the amount of staking by validators also incentivize them to also do good, and they earn money. They earn rewards. Vote slash happens when you validate data incorrectly. So this is when the validator validates a data doesn't validate properly for whatever reason, and then once the vote is made that yes, it did not validate data correctly, you lose 10% of your stake. While timeout slash happens, as a proof of stake network, as a proof of stake validator, this is your node, which is your protocol node, has to be active for a certain amount of time. So if you are inactive for longer than you're supposed to be, you get a timeout slash, and then you usually lose 1% of your stake. So that's that for being a validator. And you have the KYVE flow, the fund pool, keeping the pools funded, keeping the validators incentivized. We talked about this. Keeping the delegators incentivized by any staking rewards. How the data is stored. This is just how these are like the main feature of KYVE is just it allows for data to be stored, and then aside from those data storing, which is the main feature of the KYVE, allows the data to be stored indefinitely. And like I said, being decentralized, a lot of decisions has to be made by the community, which makes it a decentralized autonomous organization, which is sort of like everything that has to be done is done by the community. Be it when it comes to adding of a pool, community votes, should we add it or not? Creating of a storage pool, which is when the validator commits an offense, the community has to vote on it. So it's not just like, oh, it's done. It's like, this is the point of a decentralized organization, making sure that the power is back in the hands of the people and let the people decide. So that's the KYVE network. The main feature of the KYVE network allows for data to be stored permanently, immutably. You cannot change it, and it's easily retrievable in the form of snapshots. And then you can just see by the amount of people that are using the KYVE network that yes, this is something that's really, really, really like taking the next time, because you can see a lot of major blockchains are here. You have Near, you have Aurora, you have Celo, you have Arweave, you have Cosmos itself, you have Solana. And this tells you a lot that what KYVE is trying to offer is really required, but it's something that's useful in the blockchain and decentralized community. And KYVE is making it helpful, making it easy to use. And I think for the most part, that is, if you want to get into the KYVE protocol, you simply have to come. When you come to the website, I'll put a link in the description below of the video, KYVE.network, and then you launch app, and you know this is the feature of the KYVE network. And then this is your Medium blog that allows you to like sort of go through a lot of what KYVE is about. You can read up on it. I'll put the link for the documentation there and their light paper too, where you can sort of do a deep around into what KYVE is about. But I feel like I covered a lot of what KYVE is about and how KYVE works and the features in this video. So I hope it was helpful, and I hope you enjoy. I hope you enjoy. Anyway, so that's it. All right. Bye bye.